Welcome students to this new question of derivatives. This solution is presented to you by Maths Buster, which is a part of Codelites Academy. Now let us start solving this. The question is we need to find dy by dx of this function. What we can do, we can take this as one part and this as another part. Why? Because this is your u and this is your u plus v. So it is derivative of u plus v. So what is derivative of u plus v? We will look at our formula sheet. See, derivative of f of x plus or minus g of x means two functions are added or subtracted. Sum and difference rule. So just simply we take derivative of first function, then same sign plus or minus, and then derivative of second function. So it will be du by dx plus dv by dx. So we will take the differentiation of this separately just to make it little simpler. Again, I can see here two type of functions present. How many functions are there? Actually, three are there. Okay, this is your polynomial x square. This e raised to something is your exponential, and minus cos x is your trigonometric. Three functions I can see. Also, two are multiplied. Which one? X square is multiplied to e raised to minus cos x. So we will apply derivative of u into v, uv rule. Okay, means two functions are multiplied. Here how they were added, here they are multiplied. So what is the uv rule? See, here we can see uv rule. So u into v. It is u will leave alone first, then derivative of v. Okay, then you leave v alone. Okay, first if you have left u alone, second time you leave v alone and take derivative of the next term. And when you are leaving u alone, take derivative of the remaining term which is v. Now v alone, then remaining term is u. So you take derivative of u. This is how you remember the uv rule. So this is my again u and v. Okay, this u and v, don't confuse it with this new u and new v. Okay, now we will leave u alone. So x square I will leave alone. I am differentiating d by dx. Okay, x square I leave alone. I will differentiate v. What is differentiation of e raised to x? E raised to x. So same we will write it down into now we will follow chain rule. Okay, so now we will ask which function is getting applied on which one. So exponential is getting applied on minus cos x or minus cos x is getting applied on exponential. Yes, exponential function is the final result. Okay, exponential nature is getting applied on this minus cos x. This is your main function. This is your main function. This is your input for main function. Input for your main function. Okay, I will write. So what we will differentiate now by chain rule? The input. Okay, I can tell it as input or I can tell it as a function also. Okay, second function or second main function, anything you tell. But we will differentiate this input, which was for your first main function. Okay, if suppose there is, let us clarify, x square, cos of x square is there here, then still chain rule will continue. Okay, still chain rule will, and we will be differentiating d by dx of x square. Okay, why? Because again in x square, if suppose it is there, it is not there in this question. In x square, x is your variable, but what is the function? This is your power function. Okay, so x is getting squared. What is its graph? Like this, a parabola. So this is your function y is equal to x square. So if here cos of x square was there, again chain rule would have applied into d by dx of x square. Why? Because this is your next second input. X square was your second input. For what? It is input for what? It is input for cos x. It is input for your cos x. So cos x at that time would be your second main function. Like this chain rule we keep on applying till we get d by dx of x. And we know differentiation of x with respect to x is always 1. So this you don't need to solve by x raised to n. You can simply write d by dx of x is 1. This I explained when if it was cos of x square, but currently it is not, so I am erasing this. Okay. It will be x square e raised to minus cos x. Now it is minus k into a function. Can I write this as k into f of x? Why? What is your k constant? It is minus 1. So what is the, see here, we see the formula used when a multiple is applied, means a constant is multiplied to your variable. Okay, u is your variable or function, whatever you tell. So constant comes out. Where it comes out of your derivative d by dx. Yes, constant comes out of your derivatives. Okay, so this constant here is minus 1 comes out. Okay, now so what is left? Only cos x. What is the derivative of cos x? Yes, minus sin x. Okay, will I apply chain rule? Yes. What is the input for your cos x? It is x. So it will be d by dx of x. Okay. Again we will write it down x square. Okay, now was only one side of your UV rule. Okay, another side will come after plus. So we had left x square alone. Now I will leave e raised to minus cos x alone. E raised to minus cos x. Okay. Into chain rule d by dx of x square. What is d by dx of x square? 2 into x raised to 2 minus 1. That is x raised to 1. Okay, then again chain rule d by dx of, I already explained you why x square chain rule, it will be d by dx of x, because your 2 is your power function which is getting applied on this input x. So we will differentiate that input again. But obviously this is 1. This is also 1. Finally we get the result as x square e raised to minus cos x into sin x plus 2x e raised to minus cos x. This was your one part of your question. This is your next tan inverse of 1 minus x upon 1 plus x. Okay. Tan inverse, tan inverse of 1 minus x on 1 plus x. So now we will differentiate tan inverse. So here what is your main, what functions we have? First of all that we will talk. So tan inverse is one inverse trigonometric function, and this is your which function? Is your rational function. Just we need to differentiate, okay, which is which, so we understand how many functions we have. This is your inverse trigonometric function. So now what is getting applied on what, or what acts as input for what? So obviously 1 upon 1 minus x upon 1 plus x is your input for this tan inverse. So main function will be your tan inverse. So I'm now fast take the derivative of tan inverse. Yes, 1 upon 1 plus x square. 1 upon 1 plus, now what is your x square? It is x square is your, x is your input. So this full term will come. 1 minus x upon 1 plus x, the whole square. So in the next step what will happen? This we will multiply here, and the denominator of this denominator will come here. 1 plus x the whole square upon 1 plus x the whole square plus 1 minus x the whole square. Now if you apply here a plus b whole square, a minus b whole square, it might simplify. So let us see 1 plus x the whole square. Okay, if I open, what will get, if what simplification will happen? Yes, the middle terms 2ab and minus 2ab will get cancelled. Left terms will be a square here, b square here, again a square here, b square here. So it will be 2 into 1 square, that is 2, plus 2 into x square. it is 1 plus x the whole square upon 2 into 1 plus x square.
Hi there, students. Students, in this question which we have solved, the term tan inverse of 1 minus x upon 1 plus x. This term is not totally differentiated, so your answer will not end here. Why? Because chain rule will be applied here, so it will be multiplied by. Now this was your rational function is your input for tan inverse, so we will differentiate this input. So dy dx of 1 minus x upon 1 plus x. So we will simply apply u by v rule, multiplied by u by v rule formula for u by v is here. In denominator we will have v square. In numerator leave v, we will differentiate u, then subtract sun sign, then u, and differentiate v. So in denominator you will have 1 plus x the whole square, numerator we will leave v alone, 1 plus x, and differentiate u, derivative of this 1 minus x, derivative of 1 will be 0 minus derivative of x will be 1, subtraction. Now we will leave u alone, so 1 minus x, and differentiate v, that is 1 plus x. Again derivative of constant is 0, derivative of x is 1. Now see, this term and this term gets cancelled out. Okay, 1 plus x minus of 1 minus x. So you will get in numerator x plus x. It is 2x. So you will not have this term here. This will be 1. Yes, and this will be 2x. So in the next step, this will be erased. So in denominator you can take 2 common. Simply take 2 common and cancel it with this. You will have x upon 1 plus x. So this answer plus this one will be your final differentiation for this term.